Hello everyone, and welcome to 7th grade Math Module 4, Percent and Proportional Relationships. In this video, we're looking at lessons 4.5 and 4.6, Fluency with Percents. Our learning goal is to make sure we can solve percent problems by identifying the type of percent problem and applying appropriate strategies. This will help us to master Standard 7 RPA 1, compute unit rates associated with ratios of fractions, 7 RPA 2, recognize and represent proportional relationships between quantities, and 7 RPA 3, use proportional relationships to solve multi-step ratio and percent problems. We talked before about how we can use either our triangle fact family relationship between part, percent, and whole to help us solve problems involving percents. We could also use an equation like part equals percent times whole, or we could use the proportion percent over 100 equals part over whole. Remember when using the triangle method or the equation that you must use your percent as a decimal or fraction, and that when using the proportion strategy by putting the percent over 100, you are writing your percent as a fraction. Now what we're looking at today is trying to move towards using some mental math to help us with solving problems with percents. And what we need to do in order to use our mental math is to really understand the number 100 and how its multiples and factors work. So I have here a chart of all of the factors of 100. 100 goes into 100 one time. 50 goes in twice and it has two multiples, 50 and 100. 25 goes into 100 four times and it has four multiples within 100, 25, 50, 75, and 100, and so on and so forth down this chart. Now how this helps us out is if I have 50%, I know that I'm looking at one out of two pieces. So my multiples tell me how many pieces that percent is of 100%. And then how many, my factor here is what percent I'm looking at, or its multiples could be another percent I'm looking at. So for example, if I was looking at 60%, that's the third multiple of 20, and there are 5 multiples of 20 and 100, so it would be the third out of 5, so it's like 3/5. I could break it up into 5 pieces to figure out what 20% is and multiply by 3 to get 60. So let's see how we can use this with some real life problems. The 42 students who play wind instruments represent 75% of the students who are in band. How many students are in band? So if we think to what we know about our multiples of 100, 75% is one of the multiples of 25. And there are 4 25s in 100. So I have here 3 sets of 25. So if I try to figure out what would be in 25%, I can figure out better what 100% would be. So 25% would be 3 pieces. If I take that 42 and break it up in 3 pieces, so it'd be 14 students, because 14 plus 14 plus 14, those 3 25s get us to 75%. So then to get to 100%, instead of having 3 sets of 14, I would need 4 sets of 14. So 14 times 4 gets me 56. Now that's just one mental math strategy of trying to solve this problem. If instead you were using, knowing that we have here a part and a percent, you could have taken your part and divided it by your percent, so 42 divided by 75 hundredths, and you'd end up with the same thing here of 56, because 75 hundredths, that's 3/4, 3/4, so then I'm just really doing part divided by 3/4, so I end up dividing by the 3 and multiplying by the 4. 75% of the students in Jessie's class are 60 inches or taller. If there are 20 students in her class, how many students are 60 inches or taller? You can pause the video here and try to solve this using mental math and check it with a more standard strategy. So if we take 75% and really think about it, 75% is 3/4 of our 100%. There are 4 25% pieces in there, and 75% is 3 of those. So if we can figure out what 25% of the students in the class would be, then we can use that to figure out what 75% of the students in the class would be. So first we can take the number of students in the class, and we can divide it into 4 pieces for those 4 quarters to figure out that 25% would be 5 students. And then we just need to count by fives. 50% would be 10, and then 75% would be 15 students. If I used a more standard strategy, like, say, multiplying my whole with my percent as a decimal, I'd still end up with the same number of 15%, but it's a bit easier for me in my head to sit here and break 20 up into 4 pieces and then multiply it by 3 than it is to do 20 times 75 hundredths. Bobby wants to leave a tip for her waitress equal to 15% of her bill. Bobby's bill for her lunch is $18. How much money represents 15% of the bill? Pause the video here to try to solve this using a mental math strategy, and then we can check it with a standard strategy. So 15% wasn't on our list of factors and multiples that we had there, except in the 5%. And I don't know about you, but the thought of taking 18 and dividing it by 20, that doesn't really fall into mental math for me. But dividing it by 10 does. Because I know here that I could pretty easily find 10%, because that's 10 pieces of 100. So I could just take the 18, divide it by 10 to find out that 10% would be $1.80. Well, I need 15%, and 5% is half of 10%. So I can just take what I found for 10% already and cut it in half to find out that 5% would be 90 cents. So 15% would be the 10% and the 5% together. So 180 plus 90 is $2.70. Instead, if I used a more traditional strategy for this, I could have just taken my whole and multiplied by my percent as a decimal, of course, and I still would have gotten the $2.70. But one's a bit easier to do mentally, and one is not. What does this make you wonder about using mental math to solve problems with percents? Write your questions down. Then you can look up your answers online or ask a classmate or teacher for help. Thanks for watching, and remember, when you're trying this on your own, if you learned from your failures, then you succeeded.